find the reference angle. The reference angle is the distance or angle measure that an angle is away from the x-axis, away from that horizontal diameter. So the reference angle is angle away, how far away you are, angle away from the horizontal diameter. In a unit circle, this would be the x-axis, so the horizontal diameter. So on the left we have negative 150 degrees. There's my horizontal diameter. Negative 150 degrees would be counterclockwise direction, 150 degrees, so it would be located right about there. The reference angle, though, would be how much further do I need to go in order to get to the horizontal. So of course, if I've already gone 150 in blue, then that means you would need to go an additional 30 in orange. So the correct answer to this problem would be 30 degrees is my reference angle. Now for the one on the right, we're in a radian form. The philosophy is the same, the idea is the same. We're going to get to this horizontal diameter, but with radians I find it easier for myself to label a little bit to begin with and to call this 0, and since the denominator here is tenths, we're looking at 7 pi tenths, I like to call this one over here, which is pi, I like to call it 10 pi over 10, because 10 pi over 10 is equal to pi, so I'm not changing it, I'm just writing it in a common denominator, similar denominator. Okay, now what's the angle over here then? Well, start at 0. This time we're moving counterclockwise because it's positive. And we're going to move around to here, and it turns out 7 pi over 10 is going to be located right about here. Now you might not even know where 7 pi over 10 is. I know it's over 5 pi over 10, so that's why I know I'm in quadrant 2. But notice that because of the way that I labeled it, 7 pi over 10, I need to get to 10 pi over 10. It should be pretty clear that I need to add on an additional 3 pi over 10. Right? 7 plus 3 would give me 10. So that means that the reference angle here would be 3 pi tenths. Okay, pause the video, see if you can try a couple on your own here. Remember, we're looking for the angle that we are away from the horizontal diameter. So try these two problems after pausing the video, and assuming that you tried it on your own here, let's do it together. First problem, there's my horizontal diameter. My angle is 250 degrees in a counterclockwise direction, so there's 90, there's 180, this one right here would be about 250, and notice that I'm coming close to the 270, right? That's how I know I'm in quadrant 3. But remember, the blue is 250. I need to get back to the horizontal axis as quickly as possible, so I wouldn't go forward this time, I would actually come back. I'd go back this way. So the 250 overshot the 180. It overshot the horizontal diameter. How much did it overshoot by? Well, 250 is how far we went. 180 is the horizontal diameter, so that means we overshot by 70. So this orange part would be 70 degrees, and so that's our reference angle. Similarly, last one here, horizontal diameter, negative 17 pi over 15, so I'm going to label the 0 over here and my convenient 15 pi over 15, keeping that common denominator. And then moving around means I need to go 17 pi over 15 clockwise. So I need to go more than 15 pi over 15, but just a tad more. So that would be the 17 pi over 15 in a clockwise direction. And so I need to get myself back down to the x-axis, back down to this horizontal diameter. And since I went 17 pi over 15, and I was supposed to go 15 pi over 15, that means in this case I overshot by 2 pi over 15. So 2 pi over 15 is our reference angle for that problem.